Hi guys, let's learn core principle of structural design today. I would like to make it as simple as possible so that anybody with least knowledge of structure also would be able to understand concept. Structural design is the process of making any whole structure or elements so that they withstand or remains as intended to be throughout their lifetime under any environmental condition. Let's dive deep into design itself. First come first. Load consideration. Load is the internal or external impact that must carry by the structure. Permanent weight of the structure itself is known as dead loads, whereas non-structural element load, which is also permanent and superimposed on structural elements, is called superimposed dead load. Floor finishing and fixing service platform, etc., can be considered as a superimposed dead load. Variable loads on a structure like people, furniture, vehicles, etc. are called live loads or imposed loads. External loads caused by wind, seismic forces, snow, temperature effects are environmental loads. These loads can be vertical as well as horizontal. Structures are capable to withstand combined loads, which is we call it load combination. Like 1.4 times dead load plus 1.6 times live load is one of the combination. There are many structural materials there in industry nowadays. However, mainly these are the still broadly used. First one is concrete. It is strong in compression and weak in tension, hence requires steel as a reinforcement, and it is called reinforcement concrete. Steel is a strong both in tension and compression. Being ductile, it can be deformed before failure. Timber is a lightweight, renewable, and sensitive but very sensitive to moisture. Structural elements and their primary functions are mainly to transfer loads from structure to the ground. Beams is the element which resists bending and shear, and it supports slabs and transfer loads to column. Columns support beam or slabs. Ultimately, it transfers axial load and bending interaction to foundation. Slabs resist beam bending and punching shear of column. Transfer loads to beam or columns. Ultimately, foundation transfer loads safely to the ground. It also resists bearing pressure, overturning moment, and shear as well. Structural analysis and design is the procedure where first-hand calculation is verified with software iteratively until satisfactory results come out. Analysis or calculation of the internal forces and stresses using hand method or software like ETABS and SAP 2000. Verification is the checking against code requirement like Eurocode, ACI, British Standard, etc. Deflection and drift also will be checked. Detailing provides reinforcement layout of connections and joints for construction. Safety factor apply because to account for uncertainties. There should be proper checking in following aspects like serviceability, deflection limits, crack control, vibration comfort needs to be under acceptable condition. ultimate limit state, ensuring strength under maximum loads to all structural elements. Durability check for resistance to corrosion, fire, and long-term degradation. Economy provides the balance and safe solution in cost-effective way. Besides them, stability and strength also needed to be checked. Structure must resist buckling, overturning, and collapse. And strength checks includes like bending, shear, axial compression, tension, and torsion, etc. This design method mainly applied for seismic, wind, snow, etc. to resist. Seismic design means provide and practical ductile detailing, lateral load resisting systems. Wind design, where we design structure as per aerodynamic consideration, bracing systems to withstand possible extreme wind case. It facilitates soil structure interaction for settlement and control for foundation design. However, there are challenges and risks presaged in this process too. Misjudging load paths can lead to unsafe design. Over-reliance on software without understanding fundamentals can result in adverse conditions. Ignoring construction practices and site condition is also not favorable. Not updating knowledge with evolving codes and standards may lead projects economically not viable. Thus, we can conclude that these points from this conceptual backbone of structural design. Mastery comes from applying these principles to real problems, understanding code perceptions, and developing engineering judgment. Thank you for listening to me. And if you haven't subscribed the channel, please subscribe. Thank you.